Okay, so this question is from EC 2015. So let the random variable x represents the number of times a fair coin needs to toss till two consecutive head appears for the first time. The expectation of x is. First of all, you should know that what this random variable x is taking, right? So x can take. So let's read out the event. The number of times a fair coin need to be tossed till two consecutive head appears for the first time. According to description, we need to have the two consecutive heads, right? So for that, at least we are going to perform 2 times toss, right? So random variable can take the value that is 2 and 3, right? Maybe if the first toss we didn't get the head, then again after 2 consecutive tests, after tossing we get the tail, and after that we get the 2 heads consecutive. That could be the case, or first 2 tosses are the head, then tail, then last 2 tosses are the so 2, 3, 4, so on, right? Now we will have to find the expectation of this x. So associated probability of this event would be 1 divided by 2 to the power 2, 1 divided by 2 to the power q, 1 divided by 2 to the power 4, and so on. Now we will have to find the expectation of this x. How we can do that? That will be 2 into 1 by 2 square plus 3 into 1 by 2 cube plus 4 into 1 by 2 4, and so on. Now we have to solve this series, right? So we know this result, that the summation from I is equals to 1 to n and alpha to the power n, that is equal to alpha divided by 1 minus alpha, and this alpha should be less than equal to 1, right? But you see that here what we are missing in this series is 1 into 1 by 2 to the power 1. If this is in series, then it will fit to this expression, right? And then we can apply this formula. So to adjust this, what we can do, we can add, that is 2, that is 1 into 1 divided by 2 to the power 1, that we are going to add it. Then the other part would going to be remain same as it is. So 2 into 1 by 2 to the power square plus 3 into 1 by 2 to the power cube plus 4 into 1 by 2 to the power 4, and so on, right? Since we have added this one, so we will have to make the adjustment. To make the adjustment, what I am going to do, I am going to subtract 1 by 2. Now this will get cancelled and this will get cancelled, and you will get again this, right? And with this we can apply this formula, right? That is alpha is 1 by 2 divided by, so here we have square also, 1 minus 1 divided by 2 square and minus 1 by 2, right? It is going to be 1 by 2 into 4 divided by 1, and this is going to be minus 1 by 2, so it is 2 minus 1 by 2, that is 1.5, right? So the correct answer for this is 1.5. Okay, now let's move to next question. So we have this question from EC 2015. So in this question, suppose A and B are two independent events with probability of A is not equal to 0, probability of B is not equal to 0. Let A bar and B bar be their complements. So these are the complementary events. So which of the option is false? We will have to see that which of the option is false. So to what we should focus on this question is this point, that these two events are independent. And so let's check it out, that the first option is that the probability of A and B would be A into B, probability of A into B. So this is correct according to this, because these two events are the independent, and this probability of A given B is equal to A. This statement is also true. Why? Because these two events A and B are independent. Then what we can say, the happening of event B will not affect on the event A. So event B has happened, given B, that means B has happened, what will be the probability of A? That is going to be as it is, probability of A, right? Why we are saying this? Because A and B are independent. Happening of B would not affect the probability of happening of the probability of A, right? So that is going to be true statement. Now we have this probability that A union B is equal to probability of A plus B. So this is false. How? So probability of A, B, so this is A, B set A and set B. So what would be the A? So A will be this complete, right? And what will be the B? So B will be this complete, right? So you see, if we will have to see only into the A and into B only, then this area will be okay. So the point is that A plus B, or A union B, is equals to A plus B minus A intersection B, that you will have to subtract. And this is again independent event, so we can write it as like probability of A into probability of B. So this statement is wrong, and if two events A and B are independent, then their complementary event will also be independent. So this statement is true. Okay, now let's move to next question. So this question is from CS 2014. Let S be a sample space of two mutually exclusive event A and B be such that A union B is equals to S. right? So if you take the union of these two events, that is going to return you the complete sample space S. If this denotes the probability of event, the maximum value of probability of A into B is, right? So what does it mean that the two mutually exclusive? What does it mean by mutually exclusive? So mutually exclusive is nothing but, what does it mean? That in sample space, if there are samples in this space, and if you have got this outcome, then at the same time you are not going to get this outcome, right? That is what it means by mutually exclusive. So if you have got this outcome, from the sample space, then at the same time you are not going to get this outcome, right? That is what the mutually exclusive mean. So that is the one thing. And A, B, such that A union B is equal to S. So let's say that A have some sample space, A have some elements, B have some elements in it, right? And maybe A1, A2, A3, B1, B2, B3. So, and A union B will be A1, A2, A3, B1, B2, B3. And this is equal to your sample space, right? So if you find that here the probability of A would be 3 divided by 6 and probability of B would be 3 divided by 6. So that is going to be 1 by 5, 1 by 2 into 1 by 2. That is 1 by 4, that is 0.25. So the answer for this question is 0.25. But you will have question that why you have taken the same number of elements in A and B, right? What we have to find is the maximum value, right? If you take uneven sample, that is the number of sample here 2 or here 3, then what you are going to get, the probability is 2 divided by 5 into 3 divided by 5, that is going to be 6 divided by 5, and it will be, so if we divide, what we did, so 2 divided by 5, okay, so you are going to get 6 divided by 25, so that will be not maximum, right? To have this maximum, this A should have equal element, A and B should have equal element. Okay, now let's move to next question. The probability that, so this question is from CEC 2014, the probability that a given positive integer lying between 1 and 100, both exclusive, is not divisible by 2, 3 or 5. Okay, so it is not divisible by 2, 3 and 5. So 1 to 100 we will have to see. That means if it is not divisible by 2, that means we can remove all the even numbers, right? Then we will left with 1, 3, 5, 7, 9, right? And here we will left with 11, 13, 15, 17, 19, 21, 23, 25, 27 and 29, 31, 33, 35, 37 and 39, 41, 40. Okay, so let's do that this way. I have already proceeded with, I think the other way we can do that, but let's do it. 51, 53, 55, 57 and 59, 61, 63, 65, 67, 69, 71, 73, 75, 77, 79, 81, 83, 85, 87, 89, 91, 93, 95, 97, 99. Okay, finally. Now I have neglected all that are divisible by 2. Let's neglect this that are divisible by 5. So that would be this column, this row, right? 5, 15, 25. So we can neglect all this. Now let's neglect which is divisible by 3. So 3, 9, and here 15 is already neglected, so 2 times, no need to do that. And now here 21, 23, no, 27, 33 and 39, and here 45 is already neglected, so we do not have to do that. 51 and 57, 63 and 69, and here 75 is already 81 and 87, not 91 but 93 and 99. Now we are left with how many? So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So that the probability that the given positive integers lying between 1 and 100 is not divisible by this would be 26 divided by 100. So 0.26 is the correct answer. Okay, finally, now let's move to next question. Okay, so So what we have been asked that each of the 9 words in the sentence, the cute brown fox jumps over the lazy dog, is written on a separate piece of paper. The 9 pieces of paper are kept in a box. One of the pieces is drawn at random from the box. The expected length of the word drawn is. First of all, you will have to see that the length of each word, right? So we have the length here 3 and 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and 3, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 3, 4, 3, right? So that random variable can take the value that is 3, 5, and 4, right? And 3 with the probability 1, 2, 3, that is 3 divided by how many words are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. But 3, 1, 2, 3, 4. 4 3s are there, right? And this 5 with the probability of 1, 2, 3, 3 divided by 9, and 4 with the probability of 2 divided by 9, right? This one and this one, right? Now we have to find the expected value of this, right? So we can write 3 into 4 divided by 9 plus 5 into 3 divided by 9 plus 4 into 2 divided by 9, that is going to be 9, and 12 plus 15 plus 8, that is going to be 12 plus 8 is 20, 20 and plus 15 is 35 divided by 9, that will be 27, 27, and we will left with 8, that is what you will get. So the answer for this is 3.88. Okay, let's look at this question. So this question is from EC 2015. So let x belongs to 0 or 1 and y is 0 or 1 be two independent binary random variable. If probability that x takes 0 is equal to p and probability that y takes 0 is equal to q, then the probability that x plus y is greater than 1 is equal to. So we have to find this probability that sum of these two random variable is greater than 1, right? So if you see here that the value of x and y, that could be 0 0 or 0 1 or 1 0 or 1 1, then what is the value for x plus y is 0 1 1 and 2. Now we have to find the probability that x plus y is greater than equals to 1, right? So you see that these are the probability that where x plus y will be greater than or equals to 1. So you can write like this. And also one main point to observe here, that the two independent binary random variable, so these x and y's are the independent binary random variable. So we can write this probability that x plus y is greater than 1 is equal to, we can write like this, 1 minus probability that x plus y is less than 1, right? So these two are the same. So instead of finding these, we can pick this and we can subtract it from 1, and this is nothing but equals to 1 minus probability that x is equals to 0 and probability that y is equals to x is equals to 0 and y is equals to 1. Sorry, y is equals to 0, right? So y is equals to 0, and since these two probabilities are the x and y are the two events that is independent, so we can write it like probability that x is equals to 0 into probability that y is equals to 0. So that is going to be 1 minus, so probability of x is equals to 0 is p from the question, and probability that y is equals to 0 is q. So the final answer is 1 minus pq. So the correct answer for this is option D. Okay, now let's look at this question. So this question is from EC 2015. A fair dice or die with faces 1 2 3 4 5 6 is thrown repeatedly till 3 is observed for the first time. Let x denote the number of times the dice is thrown, the expected value of this x, right? So this x is the number of trials, right? And that is the random variable. And we are going to throw the dice till we observe this 3, right? So this x can take value that could be 1, 2, 3, because it may happen that we will win or we get the 3 in the first trial, or it may happen that we will not get the 3 in first trial, we will get the 3 in second trial, right? And the probability associated with would be 1 divided by 6, right? And if we are getting in the second trial, if we are getting 3 in the second trial, then in first trial we haven't got it, right? But we in second trial we got it. In 3, the first trial we haven't got it, but in the third trial we have got it, right? So the probability, you get the associated probability with this all random variable till infinity. Now we have to find the expected value of this random variable x. So that would be 1 times 1 divided by 6 plus 2 times 5 divided by 6 into 1 divided by 6 plus 3 times 5 divided by 6 square into 1 by 6 plus 4 times 5 divided by 6 cube into 1 by 6. Now we have to find this sum, right? So what we can do, we can maybe take this 1 by 6 common, so that will be 1 2 into 5 by 6 plus 3 into 5 by 6 square dot dot dot, right? Now we have to find this summation, right? So again you will have to use your prior knowledge, then only you will be proceed further, otherwise you will be end up with the calculation. So what I know is that summation from n is equals to 1 to infinity n times alpha to the power n, that is equal to alpha divided by 1 minus alpha to the power square, that is so you see, but this summation is not exactly this one. If you expand, because let me just give you an overview. If we expand this, so here if we expand this, right, so 1 times alpha to alpha, but here you see that with this one alpha is not there, and this alpha is the quantity that is less than equals to 1. So to fit, so what we can do is maybe we can, so if we go according to this, then it will be if we write the general form of this, then it will be n into alpha to the power n minus 1, summation from n is equals to 1 to infinity, right? But I know this formula, so what we can do, we can the point is that, so we can make this, what we can do, so this is, so this one is n times alpha to the power n minus 1, summation from n is equals to 0 to infinity. So what we can do is, we can, to make this formula, we can like write like this, that will be from n is equals to 0 to infinity, right? And alpha we can put outside, and now we can put this formula. So when that will be alpha times alpha divided by 1 minus alpha to square, that alpha will get cancelled. So overall this summation will be 1 by 6 times 1 divided by 1 minus alpha is 5 by 6 square, that is 1 by 6 into 36 divided by 6 minus 5, that is 1, 6. So correct answer for this is 6. Okay, let's look at this question. So this question is from EC 2015. The variance of random variable x with probability density function, and we have given this probability density function, that is 1 divided by 2 mod x e to the power minus of mod x is. So we know that variance is sigma x square, that is equal to expected value of x square minus expected value of x ka whole square. That is what, right? So for that we will have to calculate this expectation and this expectation, right? Let's do that. So let's calculate this expected value of x. So that is integration from minus infinity to 0, minus infinity to plus infinity, x half mod x e to the power minus mod x dx. We can open the mod part from minus infinity to 0. The mod, this mod will open up with the negative sign, then it will be minus of x square divided by 2 e to the power x dx, right? Because this mod will open up with negative, then negative, negative, positive. Now from 0 to infinity, that mod will open up with positive value. So here we will have x square divided by 2 e to the power minus x dx, right? And now what's the integration of this? Integration of x square e to the power x dx, right? So if you know this form, that x square e to the power ax, right? This is a general form. You can do integration by part, but that will going to take the time. It's better to remember this. So for this general, the integration is going to be e to the power ax. Now what you do, you take this x square divided by a, right, and minus differentiate this upper thing, that is going to be 2x divided by square this a square. Now again differentiate this and with the plus sign, so this is going to be alternate, and differentiate this, that you are going to get 2, and again make it a to the power q. So this is the integration of this, right? Similarly, if you can calculate this x e to the power x dx, if it is a, so what would be the integration of this? You can go using by part. What I am doing is I am directly writing the result, and if you know how to write it, it would be good. It would be good in your examination, you will save many times. So this is going to be e to the power ax. Now the here is x, so write x divided by a, and now minus differentiate this, so it is going to be 1. Now this is going to be a square, right? So this is going to be the integration of this. Now if I ask you that what would be the integration of x cube e to the power ax dx, so this is going to be a to the power ax. Now write this x cube here and a divided by a. Now differentiate this upper thing, that is going to be x square, right, and 3x cube, right, that is going to be 3x cube, 3x square, sorry, 3x square, and here a square. Now write the plus, alternate sign, plus minus plus, this is going to be 6x divided by a cube, and now minus, again differentiate this, you are going to get 6 divided by a to the power 4, right? So this is the integration of this. So you can keep this in your bucket, right? That is going to be reduce your calculation, right? So that was what and now we can proceed further. So we have to calculate this integration. So what we can do, we can put this minus 1 by 2 inside, outside. Now we are left with this x square ex. We are going to keep ex as outside. Here a is 1, right? So here we are going to keep x square divided by a. So a is already 1, right? So let me write it down so that you can follow the, then minus, take the differentiation 2x, then 1 square, then plus, take the differentiation 2 divided by 1 to the power q. That is the integration, and it will limit from minus infinity to 0. With the similar logic, you can now here you see you will have to take care of this negative thing, right? So do it carefully. Now what we can do is we can write e to the power minus x. So here a is nothing but a is minus 1. So now we will have x squared divided by minus 1 and plus, not the plus, but here we will have minus, and 2x divided by a square. So a is minus 1, ultimately we are going to 1, then plus differentiation of this one, right? So it is 2 divided by a is minus 1, so here we are going to get is minus 1 and 1, right? And the limit will be from 0 to infinity. Now put the limit. So minus 1 divided by 2 e to the power 0. So this is going to be 1 and whole thing inside is going to be 0, but we will left with this 2, and e to the power minus infinity is already 0, right? Plus 1 divided by 2, e to the power minus infinity is 0, and 0 minus 2, right? So here we will get minus 2 and plus, so this will get cancelled, we will get minus 1, and here we will have plus 1, that is going to be 0, right? So expected value of x is equals to 0. Now we have to find this expected value of x square. Okay, let's do that. So expected value of x square, that is going to be from minus infinity to infinity, and now here we will write x square, right? And x square and half mod x e to the power minus mod x dx, right? Now from minus infinity to 0, mod will open up with negative sign, so here we will have minus of x cube divided by 2 e to the power mod x and dx, plus from 0 to infinity, right? And here we will have, now mod will open up with positive sign, so x cube divided by 2 e to the power minus x dx, right? Now with the similar, you can use the by part or you can directly write down. So here we will have only x, not mod x. So what we can do is we can put this half outside. Here we will have e to the power x, a is 1, and inside we will have x cube divided by a is 1, so a minus 3x square divided by 2, sorry, 3x square divided by 1 plus 6x minus 6. This is what you are going to get, and limit will go from minus infinity to 0 and plus this term, right? So half is there, right? And now this time a is equals to minus 1, so do it carefully. So here we will have e to the power minus x. Now here what we are going to get is x cube divided by minus 1, right? And minus, here we will have 3x square divided by 1 a square, then a cube, so minus, here we will have minus 6x, and again here we are going to have, so this term will be of a square a cube, so that is why we get minus. Now a to the power 4, so that time we are going to get anyhow minus 6, and limit will be from 0 to infinity. Right, now you can put the limits. After putting the limits, you will get minus half e to the power 0, that is going to be 1, and all. So here we will have minus 6 and minus e to the power minus infinity, that is 0, and plus half e to the minus infinity is 0 minus, and here we will have 0 0 0 and minus 6. So what you are going to get is 3 and plus 3, right? Here is minus 6. I hope I have done it right, because yes, so it is going to be 6, right? So expected value of x square is 6. Now we have to find the variance, right? That means sigma x square, and that is going to be 6 minus 0 square, and that is going to be 6. So sigma x square is 6. That is the answer for this question. So this question is from EE 2015. A random variable x has probability density function fx as given this. So x is from 0 to 1, a plus bx, and otherwise it is 0. And we have given this expected value, then we have to find the probability that random variable x is less than 0.5, right? So to find this probability, right, this we can find this probability by integrating from 0 to 0.5, and fx is a plus bx dx, right? But for that we need to have the value of a and b. So we have given this info, and one more info is that if we integrate the PDF from minus infinity to infinity, in this case it would be from 0 to 1, that should be equal to the 1, right? And from here we can find that it is going to be, we will have the relation between a plus b divided by 2 is equal to 1. That is the first equation, and we can use this expected value, and so expected value of x, that is 2 by 3, is equal to 0 to 1 ax plus bx square dx. Now you can carry out the integration, that would be ax square divided by 2 plus b divided by 3 x cube from 0 to 1, and 2 divided by 3. Now a divided by 2 plus b divided by 3, that is going to be a plus b is equal to 2, right? Now we can solve this equation 1 and equation 2. So a plus b divided by 2 is equal to 1. So that is going to be b divided by 2 is equal to 1. So b is equal to 2. If b is equal to 2, then a is going to be 0, right? Now we have to find this probability, right? So here we can put from 0 to 0.5, a is 0, so b is 2x, so that is going to be x square. So integration will be x square from 0 to 0.5, so that will be 0.25. So the answer for this is 0.25. Okay, so let's look at this question. So this question is from EE 2015. two players A and B alternately keep rolling a fair dice. Person to get a six the person to get a 6 first wins the game. Given that player A start the game, the probability that A will win the game is, so what's the probability that A will win the game? And whoever will get a 6 by rolling a dice is going to win the game. But we will have to find that probability that A is going to win the game, right? So it may happen that, and who starts the game? A is going to start the game. So it may happen that A rolls the die and he wins the game. So that means he is going to get the 6 on the first roll. So this is the probability, right? Or it may happen that on the first roll he doesn't get the 6. That means he is getting 1 2 3 4 5, not 6. So what's the probability that he will not get the 6 is 5 by 6, right? And again B is going to play, but B will also not win. Then only we will be able to make A win, right? If B wins, that is not what we have to find. We have to find the probability that A will win. So A will win, maybe he will get a 6 on first roll, or he will get 6 on third roll, not the second roll. So second roll B is going to lose, right? And again A is going to win, right? Similarly, you can think that A is not going to win even at the third trial. Then A will get the chance at fifth, right? And before that everyone is going to lose the game, right? So it will be 2 to the power 4, and at the end A is going to win. And now A will get the chance at what trial? At 6th 7th, right? So before that every is going to lose the game, and now A is going to win the game, right? So this is the total probability that A is going to win the game. So we can take 1 by 6 common. So this is going to form a sum of GP, geometrical progression. So 5 by 6 square plus 5 by 6 to the power 4 plus 5 by 6 to the power 6, and so on. So this is GP. The sum of this is 1 divided by 1 minus the common factor is 5 by 6 to the power square, and 1 by 6 is going to be there. So it will be 1 by 6 into 36 divided by 36 minus 25, that will be 11, right? So that is going to be 6 by 11. So the correct answer for this is D. So this question is from 2015 EE. Two coins R and S are tossed. The four joint event, that is a head-head, tail-tail, head-tail, and tail-head, have probability 0.28, 0.18, 0.30, and 0.24 respectively. H is head and T is tail. The coin tosses are independent. R is fair, S is not. S is fair, R is not. The coin tosses are dependent. Right, so we have given this joint probabilities, right? So if it is independent, that means probability of head or head on S would be equal to probability of head of R into probability of head on S. That would be equal to 0.28, right? Because this probability is given. Similarly, what we can write that probability, this one, head on R and tail on S is equals to probability head on R into probability head on tail on S. So what I am assuming, that let's assume that these are the independent. So that should be equal to 0.30. Now if we divide these two, this will get cancelled. Alright, and so from here what we are going to get is 0.28 divided by 0.30 is equals to probability of head on S divided by probability of tail on S. Similarly, we can use these two, and from here what we can find is probability that head on S divided by probability on tail on S, because these two will get cancelled, right? And from here 0.24 divided by second one is 0.18, right? So these two are not equal, right? And these two are the same thing. So what we have assumed, that our assumption is wrong. That is, these events are not independent, they are dependent. So the correct answer for this is D. The coins tosses are dependent. So this question is again from IN 2015. The probability that thermistor randomly picked up from a production unit is defective is 0.1. The probability that out of 10 thermistors randomly picked up 3 are defective is. So again, this is a binomial distribution. So you can map this to event. So this event is basically from the binomial distribution. So you pick a thermistor that may be defective or not defective. So probability that it is defective 0.1, and the probability that it will not be defective would be 0.7. And what we have been asked, that probability that 3 are defective, so random variable that it will take value 3, that will be equal to, so out of 10 3 are defective, and out of, that would be 0.9, out of 10 7 would be not defective, right? And this can be in any possible arrangement, right? So for that we will have 10 choose 3, right? So that is going to be 10 factorial into 9 into 8 into that 7 factorial will get cancelled, and here we will have 3 into 2 into 0.1 into 0.9. Do the calculation, you will get option B, that is 0.057. Now look at this question, that is from 2015 IN. The probability density function of a random variable x is this, that is e to the power minus x for x greater than 0 and 0 otherwise. The expected value of the function this is. So the point is you should have, so the point is that how you find the expected value. So expected value of x is integration from minus infinity to infinity, and here see what you find is the expectation of x, so you write here x, then the density function, right? Now sorry, now let's suppose that here instead of x it is a function. Now how you are going to take the expected value of this function? So do the similar thing. Instead of writing x, write the gx and everything will be as it is, right? So this is how you are going to do, right? So now let's find the answer for this question. So we have been asked that expected value of gx, that is going to be integration from minus infinity to infinity. So gx is e to the power, so integration would be from 0 to infinity, right? No need to take from minus infinity to infinity. So from 0 to infinity, and gx is e to the power 3x divided by 4, and the probability density function is e to the power minus x dx. We can write this 0 to infinity e to the power, so that would be minus x divided by 4, right? And now we can take the integration, that would be e to the power minus x divided by 4 and minus 4. Integration from 0 to infinity minus 4 e to the power minus infinity, that is 0, and e to the power. So here what we are going to get is 0 minus 1. So the answer for this question is 4. So this question is again from CE, Civil Engineering, and 2015. Here we have given this PMF, that is probability mass function, and this probability mass function is from the discrete, right? And PMF of this random variable x is given, right? So that is equals to q if x is equals to 0, and that is equals to 1 minus, sorry, yeah, 1 minus q होगा, 1 minus q when x is equals to 1 and otherwise it is 0. So if you draw this PMF, so that random variable x is taking 0 or 1, right? And so 0 with the probability 0.4 and 1 with 0.6, right? So what we have to find is the variance of x. So how we can define the variance of x? That is sigma x square is equal to expected value of x square minus expected value का square, ठीक है? So overall we will have to find this expected value and the expected value of x square. So let me first find the expected value of x, that would be 0 times 0.4 plus 1 times 0.6, that is equal to 0.6. Now let's find the expected value of x square, that is going to be 0 squared into 0.4 plus 1 squared into 0.6. So that is even also going to be 0.6. So here it would be 0.6 minus 0.6 square, right? And that is going to be equal to 0.6 minus 0.36, and that will be equal to 0.24, right? So this is the answer for this question. So this question is from Civil, and we have given the probability density function of random variable x. This is the probability density function, that is from 0 to 2 and otherwise it is 0. So x divided by 4 minus x square. What we have been asked that what is the mean of this random variable x is. So mean of a random variable, right? So that means expected value of x is equal to from minus infinity to infinity x times probability density function, right, dx. So we can go for the interval 0 to 2 and x times, this is the probability density function, So x times x divided by 4 into 4 minus x square, right? So from here what we will have, that x to the power x square minus x to the power 4 divided by 4 integration from 0 to 2 dx. So that will be x cube divided by 3 minus x to the power 5 divided by 20, right? And limit will go from 0 to 2, and that will be 8 divided by 3 minus 32 divided by 20 and minus 0, right? So from here we are going to get 60, and 160 minus 96, that is going to be 4 and 64 divided by 60, right? So that is the answer. You can calculate further. So this question is from ME 2015, and we have been asked that which we have given this normally distributed function or normally distributed distribution, and we 0 is the mean for each distribution, and the question is that which one have the lowest variance. So the more spread in the distribution, more the variance, right? So this 4 is have the highest spread, right, all over the data, but this 1 has the lowest, you can say it is not in comparison to all of 3, right? So this will have the lowest variance. So the correct answer for this is 1. This question is from ME. The probability of obtaining at least 2 6 in throwing a fair dice 4 times. So what we are doing is we are throwing a dice 4 times, and what we have been asked that probability of obtaining at least कम से कम 2 6 तो आना ही चाहिए, ठीक है? तो this kind of probability can be described by the binomial distribution, right? Because what will happen that either we will be successful or failure, right? So if we are throwing a dice for 4 times, so either we will get a 6 or either we will not get a 6. So what's the probability that we will get 6 is 1 by 6. What's the probability that we will not get 1 by 6 is 5 by 6, right? So this kind of event is success failure is a binomial, and here we have number of trials that we have done is 4, right? And we have been asked that probability that x is greater than equals to 2. This we can write as 1 minus probability that x is less than equals to 2, right? Now we have to find this, so we can do that. So 1 minus, that would be, so maybe we will get no. So this is the event that you will get at least 2 6s in 4 trial, and this event describes that in 2 trial, so either you are going, this event describes that either you are going to get 0 6 or 1 6, right? So this we can write, if we are getting 0 6s, that means no success, right? So if it is no success, then all of them are unsuccessful. So with 1 by 6 with no success, and 1 or Okay, so 1 by 6 with no success and 5 by 6 with unsuccessful, and for what happened, sorry, so 5 by 6, that is going to be uh, out of or 4, or it can be any with any combination, right? So 4 C 0 plus we can get 1 success and other 3 failures, and it could be in any combination, so 4 C 1, right? Now you can carry out this calculation, so let me do that. So 1 minus 4 factorial divided by 4 factorial, that is going to be 1, for 5 to the power 4 divided by 6 to the power 4 plus 4 factorial divided by, so that is going to be 4 into 5 to the power cube and 6 to the power 4. So 6 to the power 4, 6 to the power cube is to 16. So here we will get 9 and 1296, and 5 to the power 4, 5 to the power cube is 125. So 625 and 125 into 4, that is going to be 500, right? So overall what we are going to get is 1296, sorry, 1296, and here 1625 plus 500, that is 5 to 11, 1 minus 1296. So 1296, 1125, 171, so that is going to be 171 divided by 1296. So that will go 3 4 3 2 and 5 7 19 times, and that is going to be 1 4 and 4, so 19 divided by 144. The correct answer for this is B. Okay, so let's look at this question. So this question is from Mechanical 2015. The chance of a student passing an exam is 20%. The chance of a student passing the exam and getting above 90% marks is, so here it is above, in it is 5%. Okay, so given that the student passes the examination, the probability that a student gets above 90% marks. So what we have to find, that probability that a student will get the 90% marks given student passes the exam, right? So first of all, we have given that the chance of a student passing an exam is 20%. So a student will pass the exam, the chance of it have 20%, that is 1 divided by 5. And second statement is that he passes the exam but getting 90% marks is 5%. Passes the exam, probability that he passes the exam, and also he gets 90% marks is 5%, that is 1 divided by 20, right? Yes. So now what we have to find is the probability that a student passes the exam. Given that a student passes the exam, the probability that a student get above 90%, so it get above 90%, so that would be equals to probability that this intersection, that is 1 divided by 20, and probability that passes the exam, that is 1 divided by 5, so it will be 5 divided by 20, that is 1 divided by 4. So the correct answer is B. So this question is from ME 2015. If probability of X is given, probability of Y is given, probability of X intersection Y is given, then you will have to find the value of probability y given x. So this is the conditional probability, and so probability of y given x is equals to probability of y intersection x divided by probability of x. So we have given this x intersection y, right? So that would be 1 divided by 12, and we have also given this probability of x, right? So that is 1 divided by 4, so that will be 1 divided by 3. So this is the answer for this question. This question is from EC 2015. Ram and Syam appeared in an interview for 2 vacancies in the same department. The probability of Ram's selection is 1 by 6 and thus Ramesh is 1 by 8. What is the probability that one of them will be selected? So anyone could get selected, right? So we will have to find the total probability that anyone gets selected. So if Ram gets selected with the probability of 1 by 6, then that time Ramesh will not get selected, right? That is the one case. And one case might be if Ramesh gets selected with the probability 1 by 8, that time Ram will not get selected, right? This is the total probability that we need to find. So here we will get 7 divided by 48 plus 5 divided by 48, that will be 12 divided by 48, 1 by 4. So the correct answer is B. Okay, so let's look at this question. So this question is from EE 2015 year, and we have given set A and the set B. Two numbers are randomly selected, one from each set. What is the probability that the sum of the two number equals to 16, right? So we have given these two sets, right? So sum will be between two numbers, right? So with this given set, how many sum we can do? We can perform sum 2 with 11, 2 with 12, 2 with 13, 2 with 14, 2 with 15, right? So with 2 we can perform 5, and with this 4 element, how many sum we can perform? So total possible outcome would be 4 times 5, that is 20, right? So this many possible sum we can perform, out of which sum is going to give you the 16, that would be your favorable case. So when we will add 2 with 14, then we will get, so let's write it down. So 2 plus 14, and maybe with 3 plus 13, and 4 plus 12, and 5 plus 11. So these are your favorable cases, right? So probability that you will get sum 16 is equal to 4 divided by 20, that is 1 divided by 5, that is 0.20. So the correct answer for this is A. So this question is from CS Computer Science 2015. So question is, let me read it out because writing is not good. So suppose xi for this I is equals to 1 to 3 are independent and identically distributed random variable. So this we have random variable, that is x1 comma x2 comma x3, right? These are random variable, and these are identically distributed, and all these are independents, right? Whose probability mass function, right? Whose probability mass function is given for each random variable. So what it is given, that the probability of xi is equals to 0 is equals to probability that xi takes value 1 and takes 0, both are equally likely, or 1 by 2 for I is equals to 1 to 3. define another random variable that is y, and it is x1 times x2 XOR x3, right? So where this symbol denotes the XOR operation. So what is this XOR operation? Let me tell you that. So if we have two value that is same, then it is going to return 0. So, and if two values that is different, then it is going to return 1, or it may be different like this, right? Then it is going to return 1, or it may be same like this, so it is going to return 0. So this is what the XOR operation is. Okay, now what we have to find is this conditional probability. That probability, we will have to find that probability y is equals to 0 given x is equals to 0. So what is it? Okay, now we have understood the question. Now how we can proceed? So let me give you this PMF diagram. So how many random variable do you have? You have 3 random variables, that is x1, x2 and x3. All these are independent, and this x1 takes 0 1, also x2 takes 0 1, and x3 also takes 0 1. So if I, and all the probability of 0 is 1 by 2, and this is 1 by 2, and everyone is 1 by 2 from here, right? So you can say that every probability is 1 by 2. So for this x1, so let's call this one is your the PMF of x1. So it takes 0 and 1 with the probability half and half. Similarly, you can say that for x2, it takes 0 and 1 with the probability half and half. And similarly for x3, it also takes 0 and 1 with probability half and half, right? Now define another random variable, that is y, right? So this one is given, so y so this y is given is equals to x1 x2 XOR x3, right? So what could be the value of this y given all possible value of this x1 x2? Let's find out. So what is the value that y can take, right? So this x1 and x2, x1 may be 0 and it could be 1, and with this x2 it could be 0 and it could be 1, right? Similarly, we can say that with 0, that x2 can be not like this. So what could be the possible combinations, right? So if it is 1, so x1 can be 1 0, but with x1 x2 it can be 0 0, right? And with this 1 0 it could be 1 1, right? All these are the possible values. And x3 is also, x3 can take 0 or 1, right? So now for each possible with combination of this x1 x2, we will take this. For each we will take this, we will take this 1 0 and this. Now again for each possible combination of x1 x2, we will take 1 1 1 1, right? Now let's calculate this first. So it is going to be 1 times 0, that is 0, and 0 times 0 is 0, 1 times 1 is 1, and 0 times 1 is 0, right? And with this we can have x3 0 0 0 0. Again with this 0 0 1 0, we can have x3 So this is x1 times x2 and this is x3. Again this one x1 times x2 and this was x3. We can have x3 1 1 1 1. You see that what we have been asked here, the probability that y is equals to 0 given x is equals to x3 is equals to 0. Given x3 is equals to 0, right? Yes. So given x3 is equals to 0, so these are the possible value that y can take, right? So even we can calculate this, right? So that is going to be XOR operation between these two, right? So that would be same, that means 0, it will same, that means it will return 0, it will return 1 because it is different, and same, it will return 0. Here we can also take the XOR. So say different, it will return 1, different, it will return 1, different, it will return 1, and here here it will return 0 because these are the same, and here it will return 1, right? Now these are the value of y with the different value of x1, x2 and x3, right? Now we have to find this probability y is equals to 0 given x is equals to x3 is equals to 0. Now you see where is x3 is equals to 0. x3 is here, so x3 is 0 here, 0 here, 0 here, 0 here, right? And sorry, this is the value of y that I marked right now. This is the x3, right? This one is x3, and all these are 0, x3, and here none of x3s are 0. So we can discard this while calculating the conditional probability. No need to consider this in our set. Now with this condition, what is the probability that y is equals to 0? So y is equals to 0 is 1, 2, 3 out of 4. So the answer would be probability that y is equals to 0 given x is 3 is equals to 0 is 3 divided by 4. So this is the answer for this question.